behavior of objects in space. And in general, it's worked. Until
Okay? If this surface were actually in shadow, and returning the same amount of light to your eye as this surface, which seems to be in light, this would actually have to be more reflective. There's less light hitting it, but the same amount is hitting your eye as this one, right? And so that's why you see it as lighter.
Was that confusing?
No.
Let's simplify this. Bo is saying the gradients and shadows he's painted here give your brain clues that the top is a well-lit gray
It is
surface,
shadow, right?
and the bottom is a poorly lit white surface. Clues your brain trusts because of your past experience with shadows. But, as you're beginning to see, shadows can lie to you, and do all the time.
Behind me, there are two shadows that both appear gray because we have two white lights that are facing me. Now, if we replace with a purple filter, let's see what happens to the colors you see. The shadow no longer looks gray, it looks green. So the question is, where is that green light coming from? Well, there is no green light. The shadow's gray, but it looks green. Why? Because of the color that's surrounding it. Context is everything.
This illusion uses shadow to show you that another one of your most
that true?
trustworthy sources of information about the world can be faulty. Color.
Light is something that exists in the world. It's a physical thing. And our perceptions and vision begins with light. But color does not exist in the physical world. Color is completely a construct of our brain. In fact, all our perceptions are constructs of the brain. Nothing that we see is, in fact, out there in the world. It seems completely counterintuitive, but color really makes that point.
Not buying that color is all in your head too? Well, take a look at Bo's next illusion.
We made this cube to show you that illusions are no different from our everyday perceptions. These two surfaces here look very different. The tile on the top looks very dark brown. The one on the side looks a bright orange.
So, what do you think? Are the two squares the same or vastly different colors?
Looks different. They look different.
Yeah.
This surface is exactly the same as that surface.
Yeah,
And I
I
can
know.
prove that to you by taking this tile off and putting it at the top. Now you can see that they're
What?
physically the same.
What?
If I put it back down into the region which appears to be in shadow, it now again appears bright orange. Why? What you might be amazed to learn is that this whole cube is an illusion. There is no shadow here. This surface is consistent with your past experience of shadow. So your brain interprets this surface as if it is in shadow, which it isn't. But you can't help but see it that way.
You don't realize, but color is something that your brain is imposing on the world. A feature of light that has proved useful to separate the beach from the water, or the bear from the trees. So, if shadow and color are imperfect indicators of what's happening out there, what other tools does your brain have to figure out what's going on in the world? Let's take a look. Here's an easy question. Which of these two balls is larger? The soccer ball, right?
Soccer ball.
Yeah, soccer.
Nope. The golf ball is actually much bigger. Did this illusion stump you? How is the golf ball actually bigger? Let's fill in the blanks. If this seems like a cheap shot, it is. We didn't give your brain the information it needed to solve the problem.
So it tricked
Had
us there.
shadow and color. But only after adding some perspective lines did it become clear what was going on.
Yeah? I mean, no.
Baz Rokers is a scientist at the University of Wisconsin-Madison who studies how your brain uses depth and perspective cues to make sense of the world around you.
We have two eyes, and the information through the two eyes gets processed by the brain and somehow gives us a sense of our visual world. It tells us how far things are away from us and how quickly they're moving at us.
Rokers has special access to a Los Angeles rail yard to show you how your brain uses the 2D information it gets from your eyes to make a 3D reality.
There's a lot of cues that are informative to depth, and what the brain does is it tries to put those together. The lines that are parallel, due to perspective, are eventually going to be meeting together at the horizon, so at the vanishing point.
Just as it did with the gray boxes or the Rubik's Cube illusions, your brain relies on past experiences to decide how objects in this scene are positioned. Take a second to look around the room you're sitting in. Look for the lines that mark walls meeting the ceiling, or the edges of doorways and windows. Now, look back here. Through your visual cortex,